Good morning, one and all. Myself, Asma Sultana. I'm working as an assistant professor in Mlritm in CSC department, Computer Science and Engineering department. Today, we are going to discuss about the topic Perceptron in machine learning course. So, Perceptron is nothing but it is used to build the ANN model. It is the majorly first thing to build a ANN model using some input values, and these input values consist of some weights. So perceptron first it's considered a vectors and real value inputs, and we calculate the linear combinations of these real value inputs as we consider these inputs as a x from x1 to so on till xn. For these input values we are considering a weights. So these weights are considered as a randomly. So while we are generating a output, when we are generating a output, if suppose the output is greater than is 0, then it is considered as a 1, or else it is considered as a -1. So perceptron is the first thing it is used to build an ANN, and we consider all the real values as an inputs, and we for these all the real values we consider a random weights, and we calculate the output for this ANN. So first, this is the basic architecture of your perceptron model, or you can call it as an ANN basic architecture. So first we consider input values. All these input values are represented with the circles. These circles are called as nodes. These circles are called as nodes, and each and every circle node is represented with some input value that is nothing but we are denoting with an x. So x1, x2, so on till xn. For these each and every input we are considering a random weight. We are assigning a weight for each and every input value. So these weights are considered as a random value. Any random value we can consider. So after considering an input, for input we are assigning a weight. After assigning the weight, we are calculating a summation function for these inputs and weights. So summation, how we are calculating this summation function? Using this formula. This is summation of wi and xi. So wi is nothing but a weight, and xi is nothing but a input. So if suppose let us consider we have n number. Let us consider we have a 3 input values, that is nothing but a x1, x2, x3. So for this, how we will calculate the summation value? X1 into W1 plus X2 into W2 plus X3 into W3. So this is how we'll calculate a summation function. After calculating the summation function, we are using a one activation function, that is nothing but we are using a sigmoid activation function. We have more activation functions, but we consider only some sigmoid function, and then we will generate the output. So first we are considering the input nodes. For each and every input node we are assigning the weights. After assigning the weights, we are calculating the summation function. We are calculating the all input nodes with the weights, and then we are moving to the activation function, and then we'll generate a output for this ANN model. So output is nothing but, if suppose it is greater than 0, then it is considered as a 1, and otherwise it is considered as a -1. So output is represented with a small 0. Small o is nothing but a output. Output is represented with a small o. So if suppose output is greater than or equal to 0, then it is considered as a 1, or it is considered as a -1. So if here in this perceptron model, when we are considering the inputs and outputs and generating the output, if suppose ANN model is not, it should map with a targeted output. The whatever the output we are generating for this model, it should map with the targeted output. So targeted output is predefined here. So targeted output is a predefined output. After generating the output, it should map with the targeted output. If suppose the targeted output is not mapping with the actual output, then you need to modify the weights. Modify the weights of the input values using the function, using this particular formula, that is nothing but Wi is represented with Wi plus delta Wi. So rewriting in this, we are elaborating this particular thing, particular function. So what is the actual? The Wi is equals to n into t minus o of xi. So delta Wi is nothing but your modifying the weights. So modifying the weights, what is the modification of the weights modification formula? That is nothing but n into t minus o and xi. N is nothing but a learning rate. This is defaultly represented. And next one, t is nothing but a targeted output. And o is nothing but a actual output. And x is nothing but a input value for which you need to modify the weights. So when we are modifying the weights, when targeted output is not equal to the actual output. Targeted output is defined already, and actual output is nothing but which we are finding out for a particular ANN thing. So weight modification formula is nothing but delta Wi is equals to n into t minus o of xi. So n is nothing but it's another kind of a input which is considered as a default value, that is called as a learning rate. T is nothing but a targeted output, and o is nothing but a actual output, and x is nothing but a for input which whatever the input we are considering to modify the weight. So let us consider a basic simple example to build an ANN using a AND gate. So AND gate, we are seeing an example for this perceptron problem, how an ANN is built. So let us consider one logical gate, that is nothing but a AND gate. So first, AND gate structure is nothing but a truth table of AND gate is nothing. If suppose two inputs are 0, 0, then the output is also 0. If any one of the input value is 1, then it is also 0. If any one of the input value is 0, 1, then it is considered as a 0. If two input values are 1, then the output value is 1. So simply saying, if suppose two input values are 1, then the output value is also 1. This is the basic logical gate of your AND gate, logical gate AND gate. So by using this, we'll build an ANN. So this is considered as logical gate AND is considered as an input, that is nothing but a x1 and x2. And this is the targeted output. And next, so we are considering for this input values, we are considering a randomly a weight, that is nothing but W1 is nothing but 1.2 and W2 is nothing but 0.6, and threshold value is nothing but a output value. So threshold value is an output value, and learning rate is n is equals to 0.5. So first we'll perform some iterations based on this AND gate. So first input value is nothing but a 0 and 0. So 0 and 0 is not, A is equals to 0. So let us consider this is as a and this is as a B. Input 1 as a and input 2 as a B. So input 1 value is nothing but 0. So we have considered 0, and input 2 value also we have considered as a 0. And the targeted output, what you need to get? We need to get as a 0. So now we will perform summation function for this. So first we'll draw a simple diagram to make it easy. This is x1 node 1 and this is x2 node 2. So simply saying, we'll rewrite it like this: A or B. So for this A and B, we have, these are the inputs. We are assigning some random weights. Let us consider 1.2 and 0.6. For this, we are calculating the summation function and then we are generating the output. Okay. So first input value is 0 and second input value is 0. The output should be 0. So now we are calculating the summation function. What is the summation function formula? That is nothing but summation of xi wi. So xi wi is nothing but the input we have considered as an a into w1 is equals to plus b into a into w1 plus b into w2. So now substitute these values into this particular summation formula. So a input value is 0, 0 into, and w1 value is 1.2 plus, so b input value is 0 into, and b weight value w2 value is nothing but 0.6. So 0 into anything is nothing but a 0. So the what is the actual value we got it? The actual output is 0. The target output should be also 0. So here the targeted output and actual output is equal. Both are same. So next we'll move to the next input value, that is nothing but 0 and 1. So here a value is equals to 0 and b value is equals to 1. So a is equals to 0 and b is equals to 1. So now we'll substitute this in the same formula, that is nothing but a into w1 plus b into w2. So here a value is 0 into, what is the w1 weight value? That is 1.2 plus. So what is the b value? 1 into 0.6. 0.6 is nothing but w2 value. So value will be 0.6. So the actual output we got it as an is 0.6. So 0.6 and the targeted output is also 0. So both are mapping. Now next we'll move to the another input value. Another input value, that is nothing but a 1 and 0. So a value is equals to 1 and b value is equals to 1. So a is equals to a into b1 plus, so w1 a into w1 plus b into w2. So now we'll substitute the value. A value is equals to 1 into w1 weight is 1.2 plus b value is 0. B value is 0 into w2 value is 0.6. So now the value will be 1.2. The what is the actual value we got? The actual value is nothing but 1.2. So here the targeted output should be, output is 0, but the actual output we got as an 1.2. Here the targeted output and actual output is both are not mapping. So here the targeted output is not equal to the actual output. So in such case, we need to modify the weights. So last in the previous thing, we have seen the weight modification formula, that is nothing but delta wi is equals to n into t minus o of xi. So same formula we are applying to modify the weight, in which case when targeted output is not equal to the actual output. So this is the delta wi is equals to wi plus n of t minus o into xi. So for the first we'll calculate for the weight 1. Weight 1 is equals to, so weight 1 is 1.2. So 1.2 plus, so n is nothing but a learning rate value. So learning rate value is we have considered defaultly, that is nothing but 0.5. So 0.5, and the t is nothing but a targeted output. So targeted output is defined as a 0, and what is the actual output? We got it as an 1. So into xi is nothing but the whatever the input we are considering, that is a value, it is considered as a 1. So what is the value we have got in? 0.7. So same thing you need to do for the weight 2 also. So weight 2 is nothing but 0.6 plus learning rate into minus targeted output minus actual output into the second input value, that is nothing but a b values, that is 0 is equals to 0.6. So this is the updated weights of a W1 and a W2. So now we will apply these updated weights W1 and W2 to the entire entire AND gate process again will repeat the process until it classifies perfectly, So these are the updated weights. W1 is equals to 0.7 and W2 is equals to 0.6. The same thing will follow. First X1, A and B are the inputs. Now what are the weights of A is 0.7 and 0.6. Now again we'll perform a summation function and then we'll generate the output. You need to classify perfectly. So first we'll substitute with the same thing. So A value is equals to 0 and B value is equals to, first input values are 0 and 0. So A value is 0, B value is equals to 0. Now we'll perform the activation function. So activation function is nothing but A into W1 plus B into W2. So A value is equals to 0 into 0.7 plus 0 into 0.6. Totally it is considered as a 0. Anything into 0 is 0. The same thing. So second input values are 0 and 1. So A into W1 plus B into W2. So A value is 0 into 0.7 plus next 1 into 0.6 is equals to 0.6. So here the targeted output and actual output are mapping. So we have forwarded to the next input values. So here the targeted output is 0 and the actual output is also 0. The both are matching. And next we'll go to the next input, that is nothing but A is equals to 1 and B is equals to 0. So same thing, A into W1 plus B into W2. So A value is nothing but 1. So 1 into 0.7 plus 0 into 0.6. So here the value is 0.7. Here again the targeted output is mapping with the actual output. So next we'll move to the next input values, that is nothing but 1 and 1. So same formula you need to apply. You need to perform summation function, that is A into W1 plus B into W2. So A value is equals to 1 into B value is, what is the weight 1 value? 0.7 plus what is the B value? B value is 1 into second W2 value is 0.6. So here the value is 1.3. So again, here the targeted output is mapping with the actual output. So the targeted output is equals to 1 and the actual output is equals to 1. So here the targeted output is mapping with the actual output. So this is perfectly classifying the value. This is the perfect weights of A and N. So we can classify the AND gate perfectly. So for first possibilities for 0, 0, the actual output is also 0. Here the classification done perfectly. And second input values are 0 and 1. The actual output we got it as an 0.6. We are considering as a 0. So it is also classified perfectly. And third input values are 1 and 0. So the output is also 0. The actual output we got it as an 0.7. We are considering as a 0. So it is also perfectly classified. And next thing, next fourth value is nothing but fourth input values are 1 and 1. So 1 and 1. So the output we have got as in a 1.3 and we are considering it as in a 1. So this is also 1. The targeted output is also 1. So here also it is perfectly classified. So total, so what are the perfect weights to modify this? Perfect weights to represent the AND gates are nothing but a 0.7 and 0.6. So W1 is equals to 0.7 and W2 is equals to 0.6. So this is how you need to train a perceptron model using a AND gate. So now we'll see the algorithm. So this is the basic algorithm of your perceptron model. So first we are considering the input, that is nothing but X, and next one is N, that is nothing but a learning rate, and X is nothing but a input, or you can call it as a nodes also. Okay, so first for these input we are initializing a weight which is nothing but a W. So W is represented with the initial weight, that is nothing but, if suppose you have more than one weight, you are representing with W1, so until Wn. You are initializing with the initializing with a weight for this particular x input and with some random variable. So some random value. And next, if suppose here the targeted output is equals to the actual output, we are stopping the process. If suppose the targeted output is not equal to 0, then you are modifying the weights. You are modifying the weights. The modifying the weights is for each and every training instance is x. T of x is represented. T of x is nothing but a targeted output. If suppose the targeted output is not equal to the actual output, then you are modifying the weights. In the weights formula we have seen in previously, that is nothing but Wi is represented with Wi plus delta Wi. So delta Wi is nothing but to modify the weights. So delta Wi is equals to learning rate n of t minus o of xi. So n is nothing but a learning rate, t is nothing but a targeted output, and o is nothing but a actual output. And then after modifying the weights, you are updating the weights and repeating the same process. That is nothing but you are performing again summation function. Again you are repeating the summation function until all the examples are correctly classified. All the examples are correctly classified. It means the targeted output should be equal to the actual output. So that is how you are correctly classifying the Perceptron ANN model. After finding the perfect and correct weights of your inputs, then you need to represent in a ANN structure, that is nothing but in this particular form. This is the basic structure of. So first, nodes are nothing but input values. For these input values, you are representing with a weight 1 and weight 2. And then it is moving to the summation function. And next, you are generating the output. So this is the basic representation of ANN. So this is all about this topic, that is nothing but Perceptron. Thank you.